Hey everyone, so in this presentation we'll be discussing the book we've been reading this semester called The Second Machine Age and talking about Chapter 7 of it. So the overview and the main points. Chapter 7 of The Second Machine Age focuses on productivity after the establishment of communications and information technology. And the four main points we'll be discussing will be productivity growth, the productivity paradox, complements to IT organizational changes in response to new IT. And to define IT productivity, Tech Target writes, IT productivity is a reference to the relationship between an organization's technology investments and its corresponding efficiency gains, or return on investment. IT productivity should enhance an organization's growth and promote economic well-being. Investments that can contribute to IT productivity gains include hardware, software, and expansion of the labor force. So moving into productivity growth, labor productivity growth drives an increase of the GDP per person rate. And right now, the rate of GDP growth per person has averaged 1.9% per year going back to the 1800s. And with the rule of 70, which is 70 divided by the growth rate, it would take about 36 years to double our GDP or living standards. And if the GDP rate were to increase by just 0.5%, the U.S. budget problem would be solved without any policy change, which could be very important. And looking over the graph to the right, we have the labor productivity in the business sector from 1947 to 2013. And a couple things to point out are in 1989, when the internet was first created, you can actually kind of see a lull in labor productivity, which should not make sense because technology is supposed to drive productivity. But we'll be discussing that later on in this presentation. And because of labor productivity, we are able to work shorter hours to produce the same amount of output. So now the average work week is 35 hours, but back in the day in the 1950s, you'd be working 50, 60 to 70 hours per week. And right now, 11 current labor hours is equal to 40 hours of labor in 1950. Which is pretty wild. Moving on to the next slide, we have productivity growth comes in innovations in technology and techniques of production. Through modularity, we can find more and more ways to use one technology, which opens up new markets and drives productivity. So these two pictures I have on the right are good examples of modularity, especially the top picture, where we're given a pie that is split into 4 slices, and just from these 4 slices we can create 9 different animals from only those 4 slices. So it really describes modularity, where you're given this one pie, but you can create 9 completely different things from the same thing. So you're given a technology, and from a certain technology, you can create many different things and use it for many different purposes from the same technology. And that's the same thing with the Lego example below that picture, where you have all the pieces, but you can kind of manipulate it in ways you want to serve a different purpose, whatever that may be with technology. But innovation of current technologies takes time, which affects product growth. So Hannah will cover that in the next couple slides.
Another concept that was discussed in Chapter 7 is the productivity paradox. And basically what this is the idea that with a new technology, such as electricity or a computer, an increase in productivity is not seen instantly. Instead, there's often a lag that occurs after the invention to when an increase in productivity can actually be seen. This lag is mostly due to the time it takes people to understand how to properly utilize and apply the technology in order to improve their day-to-day activities. Now, if you look at the graph, they noted and discussed this concept twice in history. The first was during during the 1890s through 1930s, or the electrification era. This time period was when electricity was invented. Initially, as you can see, there was not a huge increase in productivity with the invention of electricity. It wasn't until about 20 years later when there was a sharp increase due to the new technology and its ability to allow us to do things we could not previously do. This trend is shown with the gray line on the graph corresponding to the dates at the top. The blue line is the productivity levels in the information technology era. As you can see, they follow a very similar trend, with the increase again coming at a lag. In the IT era, it was the invention of computers that didn't become really useful until we had the IT and innovation to support it.
Okay. So as we know from the productivity paradox, technological innovations typically need to be accompanied by a complement to kind of greatly increase their productivity and push the curve out, if you will. So if we're thinking about this in terms of like information technology, as we know, like the large creation of IT systems and things like that have started allowing companies, to store and collect really large amounts of data. And we can kind of think of this as, sort of our automate and informate course tie-ins. But just these things on their own weren't really enough to make like a transform move. And so that's kind of where the complement comes in, which allows these these IT innovations to really kind of push out our productivity curve. And so sort of the complements for information technology are like redesign, kind of rethinking the business processes. And so essentially, now that companies have all this data from their automate and kind of informate stages, how can they actually take this data and do something useful with it? And so we can think of an example like Walmart. Walmart started introducing systems that would help kind of share their data with their vendors, and this allowed them to have a vendor managed inventory, and essentially kind of transformed Walmart from making 1 billion in sales a week in 1993 to 1 billion every 36 hours in 2001. Another example we can think about is CVS Pharmacy. They were having troubles with their prescription drug ordering process, and they had like really negative customer feedback. And so kind of they redesigned their whole business process and simplified it using like kind of a chain-wide new system. This simplification really increased their customer satisfaction and increased their profits greatly. And so kind of the main point of all of this is for this, these innovations to make that transform move, and to kind of see, the big results of all the investment in this technology and things. You kind of have to have these complements of redesigning your business process to actually, take advantage of it.
As far as organizational changes go, the transition from steam engine-driven plants to electricity-driven plants was one of the most impactful changes that really got the ball rolling. To really break it down, steam engine plants had large-scale axles that powered a series of pulleys, gears, and smaller crankshafts. So when it came time to transition to electricity, engineers simply replaced the steam parts with electric parts, leaving the factory layout practically the same. So it wasn't about until 30 years later that the factory layout changed to facilitate the natural workflow of materials, and this nearly tripled productivity. Other organizational changes that helped increase productivity were transitioning from lean management to total quality management and Six Sigma, digitization, which allows innovation to happen more efficiently on a much larger scale, and organizations having enterprise-wide IT systems. Organizations who used IT in the 1990s actually saw an increase in productivity growth in the 1990s and early 2000s, while companies who did not saw a decline.